As a reminder, breakout, you get 3 minutes. You guys did great the last time. We even had time for questions and clarifications, so that was spectacular. We're going to do it again with breakout session 1 starting, which I think, Leanna, that's you up. Where's a microphone? Where's a portable? Okay, there's a portable. I think we got to stand in the front for the camera to get them so they can send them across the Zoom zone. All right, please state your name and where you're from and stand in front of the podium. And I'm going to move out of the way. Okay.
Hi, everybody. I am Leanna Kelly with Mark-On Cooperative, reporting out with group number 1. So the first thing that our group discussed during breakout session number 2 was that we all agreed some baseline amount of testing for generic E. coli is helpful to understanding the microbial quality of your irrigation water. We weren't all in agreement on how frequently you should be testing. And that led into a discussion around the sanitary survey, and that any test results that you are taking and receiving really need to be within the context of your sanitary survey and understanding your watershed and where your irrigation water is coming from. The next thing that we talked about was identifying unusual events, and how probably through irrigation water testing you're not necessarily going to identify those unusual events, and that you really need to be monitoring your growing area and your irrigation water system for things like flooding or the movement of wildlife throughout your irrigation canals, tying that back into the sanitary survey and continuous monitoring. And that possibly triggering or having some type of contingency plans around when there is flooding. We do increased testing, all within the context of what unusual event you have identified to determine what's appropriate for additional testing. I was also supposed to note that several of the folks in our group were surprised to hear that a lot of growers aren't doing any testing of their irrigation water. So that was one thing that we discussed. Again, going back to developing contingency plans, we talked about being proactive and kind of thinking through different types of events that might occur within your irrigation system, and kind of thinking through what you might do, modifying different types of practices. We had one example where a grower might choose to use a floating row cover instead of overhead irrigation or overhead spray for frost protection. And the last thing that we talked about was just sharing knowledge between other stakeholders within the same irrigation water district, sharing information about unusual events. And I guess to close, we all agreed that really emphasizing the sanitary survey and maybe possibly somehow regulating what's required to be within a sanitary survey may be more valuable than regulating like the numbers and the testing and the levels of generic E. coli allowed. And that's all.
Okay, 2. Here you go. 2 up here. 2. Yep. Can you stand in front of the podium?
Hello, Raymond Yoder from Ohio. Group 2, one of the things that we very clearly identified was the variability in the water source across the country, and even from farm to farm, region to region, the ability to monitor. And one of the comments is that we never bathe in the same river twice, because a river is always a moving target. So we can test the water, and an hour later, we have other water that is our source. And then, of course, the commodity. There's a huge difference in whether we are irrigating leafy greens, or we are irrigating carrots or onions. There's so many variabilities that I can't even begin to completely identify them, but I think the farmers may understand those better than some of the regulators. identify risks and the variability. When we identify risks on our farms, whether we have animals, where are our crops being grown? Where is the strawberry patch compared to our pasture land? Is it downhill? Is it uphill? Contours of water. Where does our water flow through from our, what's the pattern on our farm? Even to the point of what's the pattern of the animals, animal intrusion, whether it's domestic, whether it's wild animals. Can we minimize? Can we eliminate the risks? Some things we can eliminate, some things we can't. Can we mitigate? Exactly. Just as I said, some of the things we can, some of the things we can't. Know your own landscape, your water source. Identify risks that are relevant on your farm. I think each farmer can do a lot to lower the risk by identifying what could be the risk on his farm. Consider the risks with portable equipment. We talked about that. The contamination of your distribution system. May you be moving an overhead irrigation system from one water source to another source, or to another crop. And it might be appropriate on the one crop, but it is not on the other crop. Consider those risks. If you find the risks, if we find risk, we need clear guidance on mitigation, whether it's chemical, whether it's mechanical, whatever it may be. We have a problem with the water. What can we do? We need guidance. We need help to correct that. Thank you.
Okay, good job. Group 3. Oh, Sharon.
Yep. Sharon Lanini with Pacific International Marketing in Salinas, California. Our group wanted to kind of start out, we came up with a thought that actually FDA really got something right in the produce rule, and that is designating the actual edible portion of the commodity in terms of water risk versus the non-edible. And the non-contact irrigation water, ag water, is a hazard, but is it actually impacting that edible portion of the crop? The sources of hazard, they vary geographically, and if you understand your risks, you probably are in a good spot to hopefully figure out what might need to be done to mitigate. And they vary widely, region to region. Some examples of hazards: weather, wildlife, landscape, flooding, drought, the list goes on. We also talked about operational decision making. If you have somebody that, for good or bad reasons, makes a bad decision and takes the water from the wrong source, you could have a problem. Also, if you have an issue with equipment, that could be an operational problem also. We also talked a little bit about this whole blossom stage and whether or not that one is right. There probably needs to be some more research and not using samples that are loaded, using more real world examples of what happens in the real world. Is that a risk? That's it.
All right, good job. Group 4.
Hi, Kate Woods with the Northwest Horticultural Council out of Washington State. So first of all, our group was pretty diverse in terms of region. We had folks from Pennsylvania, from Florida, from the Southwest, as well as from the Northwest. And one thing that really stood out was the variability, both in water source and in risks. In terms of water source, we did talk a bit about, even when you're talking about surface water, you have different risks associated with open canals, with piped systems, as well as with ponds. We separated our risks into 3 general categories. First one being people. Recreation, this was one I hadn't heard before because this hasn't been an issue in our region, but we heard from some folks in the Southwest who said sometimes in the dry canals, people go horseback riding. So that brings all sorts of fecal contamination issues and whatnot in those canals. Canal maintenance is also an issue, as well as in some more urban areas, you might have issue with septic contamination. We focused a lot of our mitigation discussions on communication, primarily with irrigation districts, because they really are the ones that are out there every day looking at the canal. They're going to see whether you have a dead animal in the water, et cetera, that could really impact your water. Another thing is just awareness and paying attention to what's happening with your water system. Moving on to our second area, we talked about animals, whether they be dead animals in the canal, alive animals such as birds, that sort of thing. I will point out from our Florida friends, we heard about alligators being an issue, as well as dairies, which sometimes the contamination from dairies is more of an air contamination towards the open canals than necessarily right next to it. Again, with mitigation, we talked a lot about communication. I'm going to point out the word ditch riders because that was one that Kristen had not heard before. But again, these are people who, for the irrigation district, are out there every day and can really give growers a lot of information about what's going on with their water system. Last category we talked about was weather. If there is a big rain event, if there's a flood, if the water temperatures are high enough that they're going to really impact the growth of pathogens. A big one for us in the Northwest is snow runoff. If it gets really hot in the summertime, the snow melts in those high mountain reservoirs and has a big impact down below. So we need to be aware of those, and we need to factor that into our decisions related to when we're going to irrigate and when we are going to harvest. We did have a lot of conversations about sampling as a part of this. I didn't necessarily reach consensus on when it is appropriate to sample or how often it is appropriate to sample, but that certainly is one of the considerations as we're looking at the various risk levels. One other thing we talked about in terms of irrigation districts is, should there be some sort of statutory requirement for them to share information with either their members or with the public? And ultimately, we decided not necessarily statutory requirement, but that it is important, whether they're sampling or not sampling, for irrigation districts to really be communicating what's going on in these water systems to their members. And that's pretty much it.
Group 5.
Hi, Manan Sharma, USDA ARS, Beltsville, Maryland, presenting for Group 5. We had a really good group from all over the country, and I think some of the examples our group brought up are really illustrative about some of the problems and potential solutions we can do for about addressing hazards and potential mitigation. One of the things we brought up was basically farm activities and human activities. What you do, what certain people, what happens on the farm can certainly influence the risk that you have. So if you've done maintenance on an irrigation water system, that might be something to keep in mind. If there are other people, like was brought up earlier about canals in the Southwest or in Huma, if they're doing water maintenance and they're cleaning out those canals, that's also something to keep in mind. And it seems like communication around those types of events are really important. So if you know that there's an irrigation water canal clean-out occurring, and if everyone who uses those canals for irrigation is aware of that, that seems like a really good way to make people aware of potential hazards. If there is something similar that could be done for, say, like regional water sources where people in certain communities are irrigating from the same water body and you know something happens there. So as another group mentioned, communication seems to be really key. Is there a way to share data, share communication through various networks like that? What's the risk inherent in your water source? So we know that water sources are hyperlocal. You know, the geographic region, the topography, types of animal activity can influence the microbial quality of the water. There are certain inherent pathogens that are present in some water sources and in some regions that are not present in others, and you need to be aware of those. And I think that affects how you mitigate, like where the mitigation occurs. Like in our group, it was brought up that there's a lot of animals in the West that graze on farms, and maybe like fencing off certain water bodies will not be really a realistic solution because it just wouldn't happen as it could occur in other countries. So maybe your mitigation needs to be moved downstream if you know that that's presenting a risk. So how do you address that? Certain inherent pathogens, like we know that we find some places have a lot more salmonella than others. What do you do to address that? And what do you do to address non-bacterial indicators or hazards, like parasites or viruses that might be present? So you really have to know your water. Maybe it requires a little more testing so you can address the proper mitigation for that as well. And then just the idea of that different commodities have different risks just through production practices or just because of the way they are. Nuts with hulls, fruits with peels, things that may be less risky than other commodities that don't have that. So is there any room? We know we have to have standards. That was brought up earlier this morning. We're not saying there shouldn't be any standards, but what is the room for flexibility in those standards once you have sufficient data and sufficient baseline? Can you establish that maybe certain events, like what was brought up in our group was maybe birds flocking just to a pond temporarily and then flying away, causing a temporary spike in, say, E. coli levels? How do you work that into your baseline and your risk, and can you design something around that? And is there a carve out for certain flexibility in the standards around very specific risks that occur on a regular basis? So that's all we have. Thank you.
I have to tell you, you guys have learned what 3 minutes is, and you've learned how to fill it. That's just not Manon. Everybody this afternoon has come in right at 3 minutes. So you guys, well, except for one group, but come on up. No pressure. Yeah.
My name is Melissa Partika. I'm from the Western Center for Food Safety at UC Davis. Group number 6 was quite diverse as well, though I can't take credit for that. I imagine that it's something to do with the organization party here, that they tried to mix us up a little bit. So what we did acknowledge in our group is that it was difficult to talk about what are region-specific risks, source-specific risks, production-specific risks, and so we just started talking about how do we deal with these types of risks. One question that came up in the beginning too is, how far away is a risk considered risky? So we've been talking about the sanitary survey or environmental assessments as they're put in there. The idea that growers are supposed to do some kind of investigation or look around, have an idea of what's happening around their water sources and potential reasonably identifiable future potential sources of contamination. But the question is, how far away do they look for those potential risks or reasonable sources of contamination? And one of our group members from Dole was saying that it's standard in their practice that they look a mile away. Some other groups might do something else. What we agreed is that there should be some kind of common sense discretion on the point of the growers. And there is the possibility, though, that there should be some kind of data-based guidance, because some growers are not going to know what is common sense to them. They don't know how far away they should be considering, how far upstream they need to be looking. So then if the growers make a reasonable decision, we say that they need to stick to them and then defend them and say, this is the decision I made about how far away I decided to look for potential risks. And if questioned about that, give their explanations and just hold their ground on that, since there's not clear, definitive guidance. We also talked about potential for multiple control points, even if there are high variability and risks across the different types of production processes. That worker training is a big problem, that you might have workers coming in from multiple commodities and some consistency in worker training so that they understand their role in not choosing the wrong water source or not contaminating the water source, surveillance of potential risky behavior or practices that are nearby. Exclusion is a thing. We know that some areas, cattle or other livestock might get into the water supply, and so exclusion might be necessary. Treatment, occasionally, we'll talk about that next, but then continued testing is a necessity, that the only reason we can validate the assessments we've done or understand our risk level is we keep going back and testing over and over again. We talked about treatments of your water supply that, while it might be effective for getting you within compliance levels for your microbial water quality standards, sometimes they can be negative towards your actual production values. So understanding whether or not treatment of your water is beneficial to you for just one compliance, but meanwhile, maybe you've got smaller crops because you're affecting your soil microbiome. Also, there's evidence that there's a possibility that treating your water doesn't actually lead to differences in the amount of bacteria that end up on your commodity at the end. I missed my 3 minutes right there. I know. So different levels of risk upstream. One of the things we talked about, I'll end on this point, is the idea of a CAFO versus grazing operations, hobby farms versus stacked manure piles, things like that, that if all those things are reasonably identifiable, maybe they need to be considered at a different risk profile.
Thank you. All right. And I will apologize to you because I've been trying to not let it ring, but I had something else in my hand covering it. All right, group number 7. Name and state.
Amy Kinder, Duda Farm Fresh Foods. I'm in Oviedo, Florida, our corporate headquarters. Group 7, I think we've heard this theme throughout the other presentations, so I think it's nice to go number 7. Risk mitigation of specific hazards, recognizing individual farms, individual commodities, commodity-specific. No, that's okay. Commodity-specific mitigation strategies for the various commodities. We have an onion grower. We had an onion grower in our group, and then me growing radishes, root crops, as well as lettuce and leafy greens. Using the data that you are collected to gain knowledge and predict the nature of your farm and your water sources as it's specific to that. Education, we discussed a lot, translating the scientifically valid data to encompass the individuality, again, farm specific, of the risk related to water. We also thought that it would be good to have a primer of the definitions and the understandings of hazards versus risks, so when you're making these assessments, you do understand the variability between those. As well as improving information on controllable H2O sources versus non-controllables. Say, again, going back to some of your regional water supplies, knowing having some predictability in those water supplies. We had representation from New Mexico, and then vastly different than, say, even Colorado or California. So, thank you.
Group 8. Name and state, please.
I'm Hank Gickless. I'm with Western Growers. We're based in California, and we captured a whole host of bullet points here, but I'm going to distill them for you rather quickly. Basically, we've distilled this down into 3 comments, right? The hazards are many and diverse. People have been talking about them up here. Weather, the season, the time to harvest, human activity, including septic systems, camping, and horseback riding in irrigation canals, wild animals, etc. We think, our group thought that the level of control over a water system is really important. The sampling, the monitoring, the frequency and location, all of those need to be tailored to the risk. And that goes into, several of the comments that occurred before about environmental assessments and sanitary surveys. I mean, everything needs to be sort of tailored to the level of control that one has over an irrigation system. When we started talking about mitigations, there were fewer things that came up currently. Right now, one of the observations were that growers, how they use the water is one of the probably most effective mitigations there is. So directing it to a non-contact type of use was one of the things that they could do. There needs to be a lot more attention on sanitizers, probably most effective mitigations there is. So directing it to a non-contact type of use was one of the things that they could do. There needs to be a lot more attention on sanitizers, particularly for use in terms of a diluent in a pesticide application or a crop protection spray. Obviously, another one, because the importance of control over an irrigation system, one of the things that is a mitigating factor is the different levels of control that you might be able to exert on a system. So places where you can limit access and things like that, or build up berms. And then the use of data, historical data, to actually demonstrate control was another potential mitigation. So if you have historical data that suggests you have a high level of control over a system, then maybe the frequency of your sampling program can be ratcheted back because you can demonstrate, control over it. And that's it.
Good job. Okay, group number 9. Number 9. Hope that's not my coffee getting. There you go.
Hi. Well, we had a variety of people in our group as well. We had growers and regulator and some association people. So basically it came down to 2. So the question was what specific risks did have to do with water. So we kind of came up with that. There are basically 2 types. There's recurring events that will happen, or something that you have to deal with. Like if you have a single water source and there's a high level of generic E. coli that's beyond what it's supposed to be. So then you would do a mitigation to make sure that, that water never touches the edible portion of the fruit. In this example, they prune the canes up to 80 centimeters and wire up, there's no fruit at the bottom part of the plant, and wire up the rest of the canes so they don't ever go down. Another interesting example of that is watercress. I have never heard of this, but this is very interesting. Because it's actually kind of grown in water, almost like a little different from cranberries, but the same type of thing where they actually fill it up with water. They do a lot of, they'll do some testing beforehand, and what they'll do is they actually lower the water level before they cut the edible portion of the fruit. And they also test that water too. So that's just, and I'm sure there's all kinds of other examples for different commodities and different fruits, because I've been in produce for 25 years and I never heard of this watercress thing before. So even all of us been around, as old people that have been around for a long time, still learn new stuff all the time. So you have to come up with the good mitigation steps for your recurring events. And then the other events are singular events that can happen. With flooding. Salmonella can persist a little longer. So the mitigation was you would maybe alter your harvest time if it's time for you to harvest. So I know we had some, not us in particular, but there were some fields in California. We had excessive flooding that we have never had before in certain parts of California. Some fields didn't make it. Also, the drought, too. So if you're sucking up the bottom of the barrel or the table or whatever, you might get some other things that you might not usually get. And then runoff, heavy rains. People have mentioned that already, heavy rains. And so you may do some more additional testing. But so for the recurring events, you need to assess your water system, know what that recurring event is, and how you can try to mitigate those risks. For a singular events, you don't necessarily know when that's going to pop up. So, but you're supposed to maintain and watch your water system. Maybe there's a dead cow in your canal. What do? You go and get it out. You run the water through it, and you do some more testing. And I think everybody really wants all specific guidance from the FDA, but you need to be careful with that because we need the leeway to do what we need to do because nobody knows your stuff like that farmer does. Getting some scientific advice from here or there is always a good thing, but be careful what you ask for. We want some guidance, but not too much, because we need to be able to do what we need to do to mitigate those risks. And that's about it.
Okay, group number 10.
Ari Havela, University of Florida. I think there's a lot of convergence in the discussions that we've heard so far. So in that sense, there's nothing new to report from our group. We had different growers regulators, company specializing in rapid detection tests. And I think the main point in our discussions was the importance of sanitary surveys and the way that they should be further developed and made into risk management instruments for the growers, so that the water quality testing is not the starting point of an action, but is the confirmation that the action that has been taken based on the sanitary survey has been adequate, which is something that should be in every HACCP-based strategy. So principles like know your water source and know the potential contamination sources. Are they animals? Are they human? That may mitigate the risk, that may define the pathogens that you need to be thinking and be concerned about, and their behavior on your product and further down in the food chain. Be prepared for unexpected events like floods, like runoff, heavy rains, all those kinds of issues. It was already discussed by other groups as well. Know your geography, know where the contamination can come from and how it can reach your product. And something we also discussed at some point, a little bit maybe of a diversion, is the issue of post-harvest die-off. Can you always assume that that will happen? No, you cannot, because some pathogens may grow after harvest. The Salmonella, Listeria will easily grow in your product. So that's where you have to go back to your hazard at the pathogen level and understand when can I assume that the pathogens will die, when I cannot assume that. And how adequate is all of that in relation to the current regulatory standards, where basically the idea is you ingest 50 mils of water in a one-time event. How does that relate to risks when you have water that reaches produce and is then being transported throughout the whole food chain? Much lower events, but much more frequent consumption events. And the way that you translate the risks from the recreational water standard to the produce, it's, as you said, it's usually complex, but we need to start thinking more about how can we make those risks more comparable.
All right, so good, you guys are coming up. This is to the remote session of our program.
Just a comment for the Southern Center remote sites, please be less wordy. You know who you are. All right, so sources of contamination came up across a bunch of the different sites. Ones that haven't been discussed, or at least that I didn't hear discussed, were industrial dumping as a potential concern. Concerns around shared water, where that water is going to a lot of places and you can't always control what your neighbor is doing. Municipal discharge, unique wildlife and unique wildlife intrusion by region. And I'll point out it wasn't only the Florida people that said alligator, South Carolina did too. Point specifically was neighbors impacting your water quality and how that relates to sampling. And the example given was if your neighbor's cleaning out a chicken house, that's going to spike your sample, so you wouldn't want to pull a sample then. Cross-contamination issues related to water sources, things like backflow prevention or improper well tapping. And then just the realization that you're going to have huge changes in contamination over the long growing seasons that a lot of these places have. The issue of bloom came up again a couple of times. The specific comment was, if there are solutions around produce for high water counts 4 days out, why are there no solutions around the bloom time itself? Probably no surprise, hurricanes came up from our sites across the South in Texas and Puerto Rico and Florida, South Carolina. Realizing that water, that flooding water, that natural disaster water has both a biological and a chemical hazard concern, and knowing that even though we don't discuss chemical hazards within the produce safety rule, it's something that our growers still need to be really aware of. The need for a discussion of having a plan B or some other option or mitigation strategy, because these natural disasters are going to happen, and if they're out of your control, there are still things you can do to help minimize the risk to the produce. So knowing what those plan Bs are. A lot of discussion about groundwater not always being an option for growers to use for a bunch of different reasons. Ones that were included were saltwater intrusion, lack of permit renewals from water districts, or periods of high demand like frost protection, leading to some other issues. So there need to be more water treatment options available, and I think we heard this from other groups, water treatments, but also water treatments that don't negatively impact the production, because we know that our growers are going to have sometimes points where they're using not desirable water. One of the best things I saw come out is this next point. Maybe instead of taking a standardized approach to controlling the hazards across the system, maybe instead we need to take a standardized approach to the control. So instead of telling us how to control, maybe we all approach the control in the same way. And this goes back to maybe a grower training on hazard analysis similar to a HACCP approach, where they identified hazards in introduction into the water sources and then develop a mitigation approach appropriate to what that potential for hazard introduction would be. Question, can the on-farm readiness review train more on this grower hazard approach and grower risk assessment? Some question around understanding pathogen survival and proliferation in the ag water environment. Once a problem gets there, how long does it last? How long does it survive, and can it actually get worse in different water systems? And then finally, is there a way we can do some pathogen testing in addition to our indicator testing, but not maybe having to react to not using or treating the water if we find a pathogen in it?
Okay, that was the South. Northeast, Elizabeth.
Okay, thanks. There was a lot of similar comments as have been covered, so I'm going to keep this to the unique comments that were made out of the Northeast. We'll start first with large-scale risks and sources of contamination. The first one that came up was the problems associated with possible influence of seawater, tidal surf water, and contamination from oil spills, overboard discharge sewage, and toxic blooms. Not unique to the Northeast, but a unique comment here. Seasonal variability came up many times. Humidity and its effect on reducing rates of die-off. Frequent precipitation and the resulting spikes in bacterial growth. In Maryland, they emphasize that there's a lot of poultry farms and a lot of poultry waste on the Delmarva Peninsula. Also, Chesapeake Bay and the stringent storm water and nutrient mitigation requirements that they have. Sources of uncontrollable outside contamination because of a fragmented landscape where farms are pocketed between residential, urban, and livestock production areas. Also, a lot of pick-your-own and petting zoos at pick-your-own operations. So those kinds of contamination sources. A big thing that was discussed was the impacts of frost, both using spray irrigation as frost control. Since it's applied weeks before harvest, should we worry about water quality? Since there would be a lot of die-off time, can we take it for granted that the risk is minimal? Also, there's a very high prevalence in environmental listeria due to the frost, freeze, thaw cycle. Potential solutions. This is a risk and a solution identified in one sentence. An engineering challenge. How to identify coolers without liquid water. Currently, there are many wet coolers, which poses a risk to post-harvest handling. We need greater communication to growers so that they understand. This goes to sort of helping them identify risks and taking steps individually on their farm. Emergency planning for drought and stormwater. Building relationships with your neighbors. And finally, need for more research and need to identify risk of illness, quantifiable risk of illness. As a starting point, ask what are the data gaps to start identifying that risk. Thanks.
That brings us to Phil.
So livestock was also identified in all of the sites in the North Central region. One other big group of comments centered around water source and characterization challenges. Urban and rural folks using rainwater, municipal and well water, as well as surface waters, whether they're large and small, public or private. The challenge of rainwater, transported water being considered surface water. Challenges around water systems easily affected by flooding and drought. A lot of characterization around how deep of a well does it have to be in order to be considered a well versus surface water. And then is less testing an option of putting more focus on monitoring and assessing risks visually and identifying low-risk situations. And then finally, uneven water usage and application methods, like drip versus overhead throughout the season. In some cases, there's dryland production with occasional irrigation use. Does that lower the risk? What kind of risk does that pose? As well as frost and transplant production, which kind of echoed what Elizabeth brought up. Yeah. Come on, you want this done fast. I'm not here.
Okay. That went so fast, I didn't even have a chance to reset my timer.
All right, so I get the rest of the time, right? So it's harder in the western states. They are quite diverse. So they weren't able to combine their answers as well this time, so they're broken by state. I'll start with Arizona. Growers desire improved cooperation with the multiple water districts. So this came up before. The multiple water districts that provide their open source water to them. Grower priorities are not always equal. Water district staff should be included in PSA training. Training of stakeholders and the general public about land use is important. They also talked about adjacent land uses like CAFOs, sheep operations, composting. Those are really typical in Arizona. Can be mitigated through buffering, harvest assessment, and continual sanitary surveys. They talked about hazards, which have already been covered in detail, different wildlife, irrigation systems, dead animals in the water, things like that. Talked about hazards that can occur through a region of growing, and that it's important that we as communities communicate information that may be a potential hazard. Get to know your neighbor. As previously mentioned, they talked about open communication between ditch drivers, ranches, and irrigation districts. Visualize your upstream and downstream impacts. So that's Arizona. California is an irrigated state, and there's multiple ways to transport water around the state, which all pose unique problems. In California, the geographical areas, farm types, and commodities are so diverse, it's really challenging to characterize them for this exercise. The impression related to ag water, even surface water, based on surveys of quality in California, is that it meets the standards. But again, it's thinking of those other things that might come up, like rain events, reptiles. Some of the more extreme California environments may have more issues with water quality. And then drought and heat impact on use of water sources. So this is something that I don't think has been brought up as much, but this might mean that the alternative source is not being monitored for quality, but it may be used from time to time for that heat and drought reduction. All right, that was California. Now Oregon. Microbial contamination, more concerns about impacts prior to arriving on the farm versus once it gets on the farm, it's pretty well controlled. Water rights and access, short versus long-term. So long-term storage and public land use products, there will be more stress on water resources in the future. Things like reservoir recharging could be a solution. A lot of reliance on snow melt, and it's a very complicated interface between the federal, state, and local agencies. And as previously mentioned, mitigation strategies. We really need more, and we need them to be communicated for application. And then finally, Washington. Based on historical data, our water sources are not generally contaminated to a level of concern. We believe there are isolated incidents related to our agricultural water. Growers in Washington use surface water for irrigation more than wells, and the use of surface water involves risks like finding dead animals, runoff, standing ponds, approximation to other risks, again, which have already been covered. Then they go specifically into the tree fruit industry. So for apples, for example, growers use overhead cooling, and they test this water prior to harvest so they know it's safe for application. So overhead cooling could not be eliminated altogether because it protects fruit from sunburn, but research conducted in Washington proves that there is bacterial die-off from UV light before harvest. Also, spray applications use ag water but are done further away from harvest. There's a lot of river-based irrigation with growers having little control over that water quality. So they have a question, where do you pull those samples from? Do you pull them at the source or do you pull them at the point of crop exposure? Risk from drip irrigation to come into contact with the harvestable portion of hops is very unlikely. So I know that's one that hasn't been mentioned so far today. Hop growers really don't feel that they should be included in this regulation based on how they use water for production. And then finally, making corrective measures based upon information from 4 years ago may not actually mitigate current risk. Crop rotation and leasing may only put covered crops under a given irrigation source intermittently, and that'll vary even within a single state like Washington. Thank you.
Okay, good job. I think everybody deserves a round of applause. You guys, again, kept us on. So on this particular one, I don't know if anybody else, did anybody else hear a question or a concern that was already covered in the rule? I know during the first breakout I made a list. You did, Phil.
Well, I have a question that came in from the North Central region.
Oh, wait, you gotta have a, no talkie without a microphone.
Question came in from the North Central region. Basically, can the FDA define surface water? Like, is a sock well or a parallel well considered surface water, or is it considered groundwater?
I know how I would answer this question, but FDA you guys come up. You're on the next part of the panel anyway. Come on up.
So in the rule, we have the definitions spelled out of surface water and groundwater, but I guess we do understand that there can be some gray area in there. So and then we have that if it's exposed to the atmosphere, then it would be surface water. So it could be honestly a situation-specific thing. So it's kind of hard for us to tell without more information on the specific sources. I don't know if there's...
Yeah, no, and then we would we would address those sorts of very specific type of scenarios that maybe you might want to share with us with more detail in guidance.
So no specific timeline for water guidance. I think the rest of guidance is early this year. Yeah.